Welcome to Math 1324. This is section 3.2. We continue to look at our banking applications and financial applications. All right, here in question 1, we would like to use continuous compounding interest formula, which I've got here. The amount A is equal to our principal multiplied by e to the RT. This is for continuous compounding. We have $9,000 now. R is 7.17%. Time is in years. That's good. We must have time in years. All right, so plug everything in. Here's the 900. Here's my R as a decimal times 5. All right, so multiply these two together. Now at this point, I don't want to write anything down. I want to get E, raise it to this number, leave it in your calculator, don't round it or anything, multiply it by 9,000, press equals, and we get the full number. Once we get the full number, then we round it to 2 decimal places for money. The thing after the 2 is a 9, so round this to be a 3. So this is the amount we would have after 5 years with that particular rate. Okay. Question 2. Question 2 is different. We have 18,000 and it is compounded monthly at a rate of 6%. Now, since it's monthly, we have a different formula. This is for n, the number of compounding periods, and n is 12. All right, so here's my 12 that appears in 2 places. N is both multiplied by time and divided by R. R is 6%. Time in the bank is 6 years. 6 times 12 is 72. 0.06 divided by 12 goes nicely, so I don't have to worry about rounding. 1 plus that number. All right, so again, at this point, I don't want to write anything down. I need to calculate 1.005, raise it to the 72nd power, and then multiply it by 18,000. This is going to be your up arrow key on your graphing calculator, or typically a Y raised to the X key to calculate this. Alright, so I'm going to round it to cents. I've got 79. The thing after the 9 is a 7. So round the 79 to an 80. Alright, question 3, we go back to continuous compounding. 7% interest, 6 years. Alright, so here's the 0.07. 6 years, which is 0.42. I calculate e to the 0.42, multiply it by 3,000. All right. Round it to the number of cents. All right, so this is 88 followed by a 4, so drop off the 4 and the 6's. All right, question 4. They're going to give us a graph. Now, what's going on here? We're looking at the amount A as a function of time. If we start off with $1,000, so you see, here's the principal. The principal is $1,000. We're going to look at different interest rates as time goes forward. So time is increasing. So we're going to compare 4%, 8%, and 12%. So you can see, based on the rate, the amount of money we're going to have at a future value. See, here's the future value. I see that we start off at 1,000. Time is increasing. As we go forward, the amounts are increasing. The higher the interest rate, the higher the amount we are eventually going to end up with. And so they just wanted you to look at this in this particular problem to see how changing the rate changes the future amount. All right, let's see. Question 5. We are going to have an account that pays 9% compounded semi-annually. We want to have $14,000 in the future. That's my future value. So the question is, how much money should I put in now? All right, so here's my formula. Let's put in what I know. I know I'm going to have a rate of 9%. Okay. It is done semi-annually, so n is 2. All right, got that. So why is the 2 in both places? Well, remember, n appears in both places. All right, so 0.09 over 2 is a nice number, plus 1. So that's 1.045 raised to the 2t. Put in how much, we don't know, but we'd like to end up with 14,000. So now let's continue moving forward here. I know that I need to figure out P, so let me get it alone. So A divided by that number will be P. And we know A is 14,000. So this is the main relationship that I need to keep. So if T is 5, I simply plug in 5 into my formula. 2 times 5 is 10, and so I need to calculate this amount. Now, the easiest way to do this is to start on the bottom. Get 1.045, raise it to the 10th power. That'll give you the bottom, but you need 1 over that number. You have a key on your calculator or phone that looks like 1 over x. If you press it, you'll get 1 over this number, and then you can simply multiply it by 14,000. If you do that, I got 9,014.98 and some more. But we're rounding it to 2 places. After the 8 is a 7, so make that a 9. 10 years, all right? I simply take my formula that I had before. See, for 5, I just plugged in 5. And now for 10, I just plug in 10. And that's the beauty of having the formula, is I can just plug in a simple number. 2 times 10 is 20, and I go through the same procedure and round it to cents. So if I want to have $14,000 in the future, and I'm willing to wait 10 years, I can put in 5,805 now. If I want the 14,000 quicker, in 5 years, then I need to invest this amount now. Okay. Question 6. How long will it take our money to double if it's compounded semi-annually? Now, what's different is the rate. All right, so let's see, semi-annually, n is 2. All right, that means there's a 2 there and a 2 there. I want my money to double, so the amount A is 2 times whatever I put in. So here's my formula. Now I'm going to divide by P, and so we get this relationship. Now, I need to get T t by itself this time. So I'm going to take the ln of both sides, the natural log, ln of 2, ln of this item. By our properties of logs, this exponent jumps in the front. All right. And so now I begin to solve for t. So that simply is the ln of 2 divided by all that stuff. So I have a formula for t, and I can simply plug in my variables. So if it's 8.6% for r, I simply plug it in, calculate this number, add 1. Okay. And so I get ln of this number, multiply it by 2. All right, that'll give you the bottom. Use your 1 over x key to give you 1 over this number, and then multiply by the ln of 2. In doing that, rounding to 2 places, it said, I get 8.23 years. That's the time for my money to double at this interest rate. If I redo the process at a higher interest rate, same procedure, plug in my r as a decimal, grind away, and I find the time is 6.25 years. So my money will double faster if the interest rate is higher.